only, please. Food, SPSS food. SPSS food. SPSS food file. So please open it. Food SPSS. Food exercise. Saya pun tak ingat ni. Never mind, just open up the file as follows, iaitu one.spss food. Saya ada one, ada tak nombor pula kat situ. Okay, done. So you will have something like this. So this is your data. Correct or not? Okay, first step, what we need to do? We need to see whether the y here is actually 0 and 1 or not. This one is 0 and 1 or not? The answer is no. Then you will need to transform it. So go to the transform, recode into different variables. Just go for the status and change it accordingly. Which is we are going to put y.n. Y.n is y new. Which is we are going to define as 1. Makan tak makan, sakit tak sakit. So 1 as 1. And then number 2 will be defined as 0. So we are going to estimate the probability of getting sick. Betul Sebab kita letak satu sick Kalau anda terbalikkan satu tu sihat pun boleh jugalah, up to you. So I'm going to analyze this one. Done already. So you will have a new variable are going to be emerged in the later part of your data. Cannot. Because the probability need to be estimated based on 0 and 1. Because the probability logic model will look into that. And then followed by another one which is the value labels. Value labels ni nak pakai apa? Value labels of what? Value labels of y.n will be as follows, which is 0. We are going to define it as what? 0 ni apa? Healthy. Okay, and then number 1 is sick. Okay, sick. So do not forget to run also the value label. So after you run the value label, you will have something like this, which is healthy and sick there at the y.n variable. Now, let us analyze it together. So first of all, go to the analyze, followed by another one which is the regression, and then binary logistic. And then you are going to insert the y.n inside the dependent. Why I'm not inserting the status? Because the status is 1 and 2. We need to put the 1 and 0. Okay, just put inside the here y.n, which is already being defined as 0 and 1, and our covariate. Okay, let's say you are going to make it as a in a robust manner. So this is a robust. What I meant by robust, masukkan je semua sekali. Okay, so you can also make it as a hierarchical. What I meant by hierarchical, you can insert one by one. Next. You also can insert it based on the combination. What's the combination? Gabungan, which is this one. Okay, so let me just do the same thing yang simple dulu. Kita buat yang simple. X1 and X5 are going to be inserted inside the blocks. The method also here can be changed into the forward conditional, ward conditional, backward, and so on. Followed by another one which is a categorical. All these things are categorical, right? And then insert it as a categorical variable, indicated as the last. What are going to be appear here is those who are eating it. Faham Sebab we are going to use the reference of the last, which is 2. Makan 1 kan? Tak makan is 2. So whatever is going to be come out in our data output are going to be referenced or referred as those who are eating it. And then click continue. Followed by another one is option. Click this 3 button, classification plot, Hosmer-Lameshaw, and CI. And then click continue. And then last but not least is click the paste button. After you click paste, then you are going to generate the syntax and run the syntax accordingly. When you run the syntax, you are going to be seeing this kind of table are going to be produced for you. So you have a case processing summary, dependence encoding whatsoever, and let us begin to interpret it. Dah keluar belum? Belum saya hitung. With regard to this, some of you might remember that before this we learned about the cross-tabbing. So cross-tabbing enable you to analyze in a singular manner. Means that status, status ni pun salah. Status ni should be inserted inside a column. And then you need to insert the ayam, which is the X1, and then followed by the X2, and then followed by the X3, and so on until the X5. All these food are going to be inserted inside the row. And then you have the statistics radio button over there. You can click it and then request for the chi-square, contingency coefficient, pi n minus b. This one is all pseudo R, and then followed by the risk. After that, you click the continue, and last but not least is the paste. After you are doing that, it's going to be generated something like this, which is this one is actually defined as singular analysis for each of the food. Contoh anda tengok. You tengok satu-satu. Ayam. So the ayam here is makan tak makan as follows. The result is not statistically significant. And then there is no cells that have expected count less than 5, which is more than 20%, is no. And then approximate significant also indicate that the level is more than 0.05. That means there is no significant association. And then we can see here is the odd ratio is more than 1 or less than 1. It's less than 1. It is not risk lah. Less than 1 kan. So nasi lemak. So let us see on the nasi lemak. Nasi lemak have 1.758. It is not statistically significant because it is not more than 3.814 pun in the first place. And therefore, it is also not statistically significant. It is not significantly associated. It is also not statistically significant in terms of the OR. Even though the OR is more than 1, it is not statistically significant because the 95 CI is actually crossing the 0. Why? Because 0.7 is actually crossing the 0 until get 3.7. So the 1, the value of 1. Why we use the 1? Because the null for the OR or RR is actually 1. Okay, let us go into another one, which is the mi goreng. So the mi goreng is sakit and tak sakit as follows. And then we found out that the level also is more than 0.05, which is not statistically significant. That means there is no significant association. So the symmetric measure is also the same, which is more than 0.05, which is we are going to say that the pseudo R is also not significant. And then we are going to see that the risk estimate here for the OR is 1.4, is still more than 1. Seems like a risk, but it's actually crossing 1, and therefore it's not statistically significant. So what about the air tebu? So air tebu is a little bit more, which is we can find that the value is actually more than 3.814, which is the value is less than 0.05, which is the significantly associated. It is significantly associated with the status of those who are sakit or not sakit. And then we find out the symmetric measures indicate that it is the pseudo R value is more than 0.2. So it's statistically significant. So that means it's statistically significantly associated. And then we find out that the value is actually more than 1. It's a risk for the people who are getting sick. But whether it is statistically significant or not, we need to see whether it's langgar or not langgar. Kita find out that dia tak langgar. Dia tak langgar number 1. That means it is statistically significant.
No risk.
Yes. That means it is risk. That means it is risk.
Oh,
yes, because it is more than 1. If you find out that the value is actually less than 1, that means it's no risk. But this one is actually more than 1. More than 1 is meant that is excess risk. So if you see something to do with 2.4 like this, and then you must remember your null is 1, you must try to deduct. 2.4 deduct 1 dapat berapa? 1.4. That means how many excess risk that you have? 140 lah. 140 is actually the excess risk related to this kind of position ataupun this kind of issues. Faham kan? If you are going to talk about the OR lah. If you are going to talk about the cohort is around 1.6. Okay? And then for the eye swarm, you can see that there is no statistical significance. This one, it is more than 1 risk, tapi is not significant. Faham? So in a nutshell, I just want to ask you, what is the most significant culprit in this case? Yes, the air tebu are going to be the risk. Why? Because the OR are indicated that the value is more than 1 and it is also statistically significant. But whether this one is still significant of risk based on the people who are eating all, we need to run for the model. That's why kita buat apa yang dipanggil sebagai logistic regression just now. So when we run the logistic regression, we want to match, because this one, logistic regression is actually the final part, not the first part. The first part is the crosstab, the binary, the bivariate analysis. This one is actually a multivariate. We are going to analyze this one at the later part. We are going to analyze this one when it is become a holistic nature, which is nasi lemak. We can see over here is 1.9. This one, you can see, air tebu is still showing the significant. And in fact, it's improving. Just now it's 2.4, right? Now it's 2.7. So this one is adjusted or not adjusted? This is the example of adjusted. Because individually it's 2.4, but when we compare it against the other component of the food, it is showing the most idealistic OR for us to make an interpretation and control. So what you need to do for the air tebu? Further investigation. What you need to further investigate in the air tebu? You need to sample it. What you need to do, even you not sample it before, find the source. So, when you talk about the accessories, you must also understand, let's say you have two. You have two variables that are significantly predictor. So, which one that you want to focus? Of course, the highest one. And then, how much, what to do in terms of prioritize it is you looking into the accessories, as I mentioned, whether the value is actually more or less. Macam ni kan, dia more than 1. You nampak tak? I swarm tadi is less than 1 kan? I can't remember. It's less than 1, right? Something to do with the I swarm is less than... Oh, tak nak. Ada satu tadi yang less than 1. Which one is less than 1? This one. The ayam is actually less than 1, right? Less than 1. Less than 1 also known in epidemiology as a protective effect. You see, the ayam. Seems like ayam, when those who are eating ayam will not get sick. Faham tak? In the other terms lah. In the other terms, when we see something like less than 1, that means there's a protective effect. Even though it looks like a protective effect, it's not significant lah. But for your information, in a epidemiological perspective, when the exponential B or OR is actually more than 1, it's a risk. When it is less than 1, it's a protective effect. It's nearly 1, that means not significant. Okay, faham tak apa yang saya cerita ni? Why we need to learn and understand about the logistic regression.
Kita tengok signifikan, dia pun dah.
Yes. Sometimes, if you look at the significant, you can see that one. However, it is not accurate because of the p-hacking. Probability hacking can be done for your data. The most significant important is actually looking for the identified CI. Why the CI is important also? To compare. Okay, I took one example. This one is already being done or already happened in a place of A. Let's say. How we want to compare it in the place of B? You rerun the same thing, but you split it. After you split it, what will happen? They will give some indices, correct or not? The OR, the everything are going to be changed. And of course, you can see the CI. The CI also are going to be changed according to the splitting mechanism. Let us try it a little bit. So just go over here and then go to the split file and let me just split it according to the gender, just for the sake of fun. Okay, we can just allow here to be splitting as follows. And I'm going to insert it on the top of the logistic regression model. And do not forget to do what? Split file of dot. So I'm going to rerun it again by just introducing the sort file over there. And I'm going to get the two table like this. And this table is quite useful in terms of answering our friend's idea whether we can see different or not. You see, the air tebu among male is actually 6 times higher, whereby when we segregate it among the female, it is actually not significant. So that is the functions of using the splitting mechanism as one of the idea given lah by your friend just now. Whether, apa tadi soalan awak? Kenapa nak kena pakai P daripada kita pakai CI. So when you use CI, you can see clearly that are something to do with the gender of male as compared to the gender of female with regard to the air tebu. In term of air tebu itself pun, kita boleh nampak bahawa the air tebu among male is something to do as compared to the air tebu among female. Sebab male lebih suka minum air tebu contohnya. Contohlah, in this case lah. Ini hypothetical data kan. So, that is actually talking about all the data. I really hope that you have a lot of time here to try simulate whatever that I did. And then 4:30 kita end our session. So now saya nak tanya tuan-tuan dan puan, betul-betul faham ke, tak faham ke, tak faham ke, ataupun kita nak balik je terus. Boleh nampak So if I give you another file or another data, can you do that? Same you will able to make an interpretation but of course lah, sometimes maybe the interpretation is not right or wrong. That is where I am or whatever pakar yang ada untuk guide you. So remember, kenapa you buat satu-satu tadi? Why you do it one by one? Why you do it one by one like this? Okay, this is the example. Why I'm doing it one by one. Okay, if you can see, my code as follows is actually looking towards the analysis of one by one. Singularity of the output, but in the different context of male and female. Nampak? Macam ni saya buat chi-square among male and then chi-square among female. So, this one is called bivariate analysis. We are going to learn about the nature of the data first according to the splitting. Nampak? If you run for the air tebu based on the chi-square, you will find out that there is no significant association. Okay, you see, there is no significant association. If you run it inside the risk estimate also, you will see there is no significant association. Interestingly, right? And then when you run it under the logistic regression, then you find out that this is one of the risks. So that's why the logistic regression is one of the idea or one of the important components for the ADET students need to understand. When to use it, how to use it, so that you can justify accordingly what is the issues with regard to this apa nama ni? Issues lah, apa? Investigation lah kan. Dah siap. Okay, cuba try buat. Saya bagi masa. Ke nak data lain? Nak data lain saya bagi.